Welcome, everybody, to another episode of Dave Cooper Live Product Spotlight. And today's going to be a great day. We are all going all the way to Canada. And we are not only just going to Canada, we are going to talk about an architectural firm in Canada that not only designs homes and buildings, residential, commercial, they also do it in off-site construction, but they are also into innovation. They also are into technology. They also invent things. They're also looking to run buildings on DC power only. So today is going to be jam-packed with all kinds of information. We're going to go from electricity all the way to solar power and everything in between. So I'm really excited about today's episode. So stick with us, because at Dave Cooper Live, we are bringing you the people and the processes that are building it better. Our guests and topics include experts in building systems, to building science, to building codes, and the tech used to build it better. We are seeking out the best and the brightest in construction and discovering all the ways that innovative building comes to life. And today is no different. But before we get started, I once again have to thank our sponsors, Forward Solutions Group. Ben Hershey, Joe Butler, you guys rock. They are a team with more than 175 years of experience developing and specifying manufacturing for panelized volumetric modular industries with best practices in development and implementation. They offer consulting with investors, developers, manufacturers, builders, and using offsite manufacturing methods. Forward Solutions is driving companies to succeed where others have failed. To reach out to them, please contact Ben at forwardsolutionsgroup.com, and I will put that information in the ticker below. So once again, you guys rock. Thank you for sponsoring us, because without our sponsors, we cannot continue to bring you all this great content. Now, with that said, I want to bring into the show, let me go over here, Zenon Radewych. I know I got his name right. I've been practicing it. So let's bring Zenon in and let's get this kicked off with WZMH Architects. Hey, Zenon,
Hello.
how you doing, man?
Very good, thanks. Good, great.
I love it. Zenon, thank you so much for joining us today out of your busy schedule. We were just talking before the show, like, man, there's meeting after meeting with the Zoom calls and technology, and I understand that completely. So thank you for taking time out of your day.
No worries. This is great stuff.
So Zenon, let's hop right into this. There's a ton to unpack with everything, and you heard in my intro. You know, you're not just an architect. You guys have an innovation lab. You're doing research. You're building apps. You're working with solar power. You're working with sensors in floors. I just don't even know where to begin or end on this. So I think we just begin where we always do, and we tell everybody that we are live on LinkedIn, YouTube, Facebook, and Twitch. Why are we on Twitch, Zenon?
I have no idea. I don't even know what Twitch is.
I love it. Twitch is where all the young people are, and that's why we're on Twitch. Us older folks don't know what it is, but we should, because we need more younger people in this space. So if you would, please hit that like and share button right now, and let's hop into this. So Zenon, why don't you take the first 3 to 5 minutes and tell us everything about yourself? We want to know everything from the moment you were born to this very moment in time, starting right now. Go for it.
Okay, so the moment I was born in Canada. My name is Zenon, as you know, and so I was named Zenon because it's the last letter in the alphabet, and I have 4 older brothers, and my mom and dad said, okay, this is gonna be the last baby, and so we're gonna name this baby with the letter Z because it's the last letter in the alphabet. So they had 5, and that was enough. So that's called, when I started. But fast forward to, high school, before university, I wanted to go into architecture. I loved the idea about, being behind designing and drawing buildings. So I went into architecture, and, ever since, it's been a lot of fun. And, I have to tell you that I do love my job. I love going to work every day, and I love, being part of the whole process of seeing buildings built. But specifically call it, in the last, 3 or 4 years, but even going further back, our industry is a pretty competitive industry, the architectural business, the business of designing buildings and designing sites. We started looking very closely, at our business and how we remain competitive, how we kind of showcase to our clients that we are, call it, innovative, that we are forward thinking. And one thing we started looking at, years ago was, was prefab modular offsite, and we realized that this is going to be the future. It makes a lot of sense. Why aren't we doing it? I always tell people that we haven't changed the way we build buildings. We still use hammers and nails that were used 100 years ago. Maybe they look a bit different, but we're still using the same tools, the same methods, more or less. Things really haven't changed, right? Other industries have really well adapted, have really progressed, but construction is one that really hasn't changed, and it should, right? There's many reasons why it should. So we started looking at that in our firm. How do we actually start to kind of look at how we design buildings differently, how they're actually built, constructed, how they're procured, stuff like that. And that's when we got into prefab and modular and offsite. But very quickly, too, we started realizing the opportunity. And I think this is for the people that are on Twitch, the young kids that are on Twitch. This is now a profession, an industry that's actually, call it, well behind every other industry that is now looking at IoT, the IoT world, electronics, gaming, all that kind of stuff to integrate into our industry. So for the young listeners that are out there, you start thinking about getting into our industry because there's a lot of opportunity to make change. Like, this is one industry where there's been no change. If you get involved now, you can make a lot of change. And I think a lot of young kids, if they were to enter our industry, they would probably make a lot of change happen very quickly. So I think we need a lot of young listeners and a lot of young, call it, talent, kind of going from, other industries, joining our industry and bringing that kind of, fresh thought process in. So that's a cool thing. Sorry for going off topic about myself. But anyway, so getting back to myself and the firm and stuff like that, when we looked at prefab, we very quickly realized, hey, the IoT, the smart building spectrum makes a lot of sense, and we've got to integrate both of them. So in the last 3 or 4 years, we've been spending a lot of time doing a lot of R&D work, getting pilot programs built. Some projects are already starting that integrate prefab and IoT. Some still independent, but the whole idea of smart building technology with IoT tied into prefab is kind of, where things have gone. And that's been my focus. That's kind of the world that I live and breathe in these days. It's very much on the smart building side with prefab. And I'm loving it. I'm loving it more than ever. It's a lot of fun. There's so much that's out there. Again, when you look from other industries to kind of bring into this spectrum, it's making it a lot more exciting. So I know I went a bit off topic about, myself, but that's kind of myself. That's who I am.
Listen, this is what it's all about. It's not off topic at all. And I think for people to understand who you are and how fast you're talking, I mean, you got a lot to say. You got a lot on your mind. And this is what's going to be so great about it. Tell me just a little bit about WZMH Architects. How big are you? Tell us a little bit about your firm, the projects you're working on. And then I want to jump into your presentation because you're going to walk us through some of these things.
Cool. So WZMH, WZ or WZMH, right, was born in 1961 in Toronto. It was originally called Webb Zarafa Menkes Housden. When we started off in 1961, we were doing buildings mainly in Toronto and in Montreal, then across Canada, then a lot in the US, and then we kind of expanded internationally. We are basically headquartered in Toronto. Our firm basically does a lot of high-rise commercial, high-rise mid-rise res. We do institutional work. We do data centers, mission critical. So we do a lot of different building types. A lot in Canada, in North America, and overseas in the Middle East and North Africa, in Asia, etc. So an architectural firm where we float around about 150 people, and a good mix of people in the office between designers and technical people, building scientists, and again, because of our R&D work into the call it smart building side, the IoT world, we've actually brought people on board in our office that are actually software engineers, industrial designers, people that actually don't actually have an architectural background, but have that background that's actually helping us develop these technologies and stuff. So we've really kind of progressed from a traditional architectural firm to a firm that basically now obviously still designs buildings, but has this small little arm that's R&D related, right, that covers off expertise beyond architecture.
Yeah, for sure. So, I mean, I don't know if it's a small little arm. I think it's, I mean, it's drive out of the innovation and the stuff you're getting ready to show us here moving forward. So why don't we stop right there and jump into your presentation? I'll pull it up and let's get through this.
Okay, cool.
All right.
Am I driving the screen or are you driving the screen?
You're driving the screen.
Okay. So the first slide here is basically kind of a summary of kind of what we've done in the last 3 years, 3 years plus in terms of the innovation side. And I'll go through some of these ideas, in the next few minutes or next half hour. But I think the idea here is that, we're again very much focused on the prefab modular, and whether it's the complete building or a part of the building, we were looking at both, right? And again, how we integrate electronics, smart buildings, the IoT world into these components. And when we started all of this, and you know, I'm not an engineer, that's not my background, but when we started all of this and we started playing with, you know, the IoT world, sensors and things like that, we realized very quickly there's a thing called AC and DC, right? In terms of power. And I really didn't know anything about AC and DC other than the band, right? But there's some good stuff out there, and even some good movies about the whole history of AC and DC power. But we realize very much that we're living in a DC world, believe it or not. You know, where we live, work, and play. You know, our phones, our cameras, our computers, our speakers, our security systems, all these things that we have, our lighting, you know, it's all low voltage based. It's all DC based, but we basically transform because we have, you know, a heavy AC infrastructure feeding all of these devices. And again, you know, this DC world I'm talking about, it's not the last 5 years, it's the last like 30 years. You know, we were putting in LED lights into buildings 30 years ago, right? Security systems, you know, 30 years ago, AV systems, etc. So we've been actually living in this DC world for a long time. We just don't realize it. So our idea is, when we started playing with DC, is to basically push the AC envelope as far back as possible, meaning we could never eliminate it, but we could have call it a larger DC highway in our buildings, and called, you know, a smaller AC highway. That's kind of our goal, and you'll see that goal throughout a lot of our ideas that I'm going to present today. So, you know, if you were to kind of, you know, look at what we're doing, it's very much about prefab, it's very much about smart buildings, and very much about the DC side of the world. Make sense, guys?
Yeah, it's making complete sense. And you know, it'll be interesting to talk a little bit further on this. I know we're going to get through your deck, but you know, what has to happen to actually make a building fully DC? Why can't we, or can we? So I mean, these are all going to be questions that I'm going to have for you. So keep rocking and rolling, and show us how you're integrating this.
Okay, cool. So one of the first things that we actually developed, the first called invention from our office, was this thing called the intelligent structural panel. So basically, it's this panel that you see here in both of these pictures, and it's basically like a 2-inch thick floor. And so basically, it replaces concrete floors or concrete and steel deck floors with a 2-inch floor. Now, we didn't invent the actual structural panel. That was invented by actually some Canadians and guys from the UK. It's basically like a sandwich. It's a steel plate and a second steel plate on the bottom, and the middle is basically like a core, okay, like a resin core. And because of that plate assembly, or that sandwich assembly, it makes it very, very strong, okay, but also makes it very light and very thin. And so when we started looking at this product, again, starting off in the prefab world, basically prefabbing floor systems out of these plates, okay, that you could really get in any size, like 10 feet by 30 feet. So 3 plates would make up like a typical core in a building. We realized, wait a minute, when they're making these plates and making this sandwich, as they're making a sandwich, why don't we insert in the sandwich some systems, some, you know, called wiring or whatever it is, that could actually be used to plug in our light fixtures, our fans, you know, have motors, you know, security systems, all these different things. Let's plug them into this prefabricated, you know, sandwich, right? So that's how we invented the intelligent structural panel. It was somebody else's structural idea, and we simply came up with this idea of creating a highway that we place inside the actual panel, okay, that basically allows us to plug and play different devices. And we kind of call it the 10-in-1. Like if you have something that's prefabricated, if we could now put things inside of that prefabricated component, other things like electrical, IT, security, then all of a sudden you have this, like, you know, bigger bang for your buck solution when you build buildings. Not only are you dropping down prefabricated structural floor panels, but you're dropping down a good section or a good component of the IT, the electrical, all that kind of stuff. So the building gets built a lot faster, and those components are built, you know, in a warehouse environment where the quality is a lot easier to do, right? So the whole idea about the panel is building buildings in a prefabricated way that has basically a highway in the panel where you basically install plug and play different devices. And you can actually see from this picture right here, or actually this picture right here, we've plugged in different things, light fixtures, like I said, cameras, security cameras, fans, motors, different things you plug into the panel. And the plugs are basically, right now we use what they call an RJ45 plug. It's the end connector of a typical Cat5 or Cat6 cable, the same cable you have in your home for internet access, etc. Right?
Yeah.
That's basically the way we plug things in. So there's no electrical boxes, none of that. It's all low voltage, very safe. Anybody could plug this stuff in. It doesn't have to be an electrician. Anybody could plug it in, and away you go. So that's kind of the concept.
I think you sent me a video on this. You want me to pull it up and we can show?
Yeah, go play it.
I think this is it. Is this it right here?
That's it right there.
Yeah. Let me, because there's no sound to this. So why don't you walk through what's going on in this 2-minute video?
Okay, so right now you're looking at the panel itself, the top of the panel. You can see it's basically a clean panel. At the very end, the panel kinks, and we actually have a heating cooling system, fan powered. There's a ceiling below the actual structural panel, which doesn't have to be there. Everything could be suspended from the panel itself, but we have a ceiling because a lot of the components require like a finished ceiling. We have a roller shade, and the aluminum there represents basically the exterior curtain wall, the exterior envelope of a building with a solar panel built into it. So again, this is just the panel, but now in a second, you're going to see a person in our office plug in things. So they're going to now start plugging in, for example, a light fixture. So you can see how easy it is to plug things in. That's actually a light built into a stairwell handrail, like for emergency exiting, right? But you can see how easily they plug things in to the panel, and everything basically just turns on. So again, no junction boxes, no electricians that have to run wires back and forth. The highway is built into the panels, and you simply plug in these devices in any port. Like, so those ports where the gentleman is plugging these things into, they're not assigned for those specific items. Like, he plugged in a fan, you'll see the fan turn on by the, okay. But so the ports are basically a port that you could plug anything into, but on the computer side, on your laptop, you actually define what those ports do. So when you plug something in, it'll say it's a light, and then you could actually have that light talk to a fan or adjust the dimming. Like, you could do all these different things at the computer end, right? So the idea basically is complete flexibility, complete plug and play, right? It's also very safe, very fast, efficient, but you make your building truly smart by having this highway, right, that's connected back to, called a computer. At that computer, you define what every connected device does and how it talks to all the other devices. That's how you make the building smart.
And you're plugging, it looks like those just USB-C plugs? Are they USB plugs? I mean, what are you plugging in? It doesn't look like your typical outlet to me.
No, so those are the RJ45 plugs, but you're right. They actually can. We're right now playing with the idea of USB-C or USB plugs, but they are RJ45 plugs, right? That basically we plug in. And this is basically an example of because of the solar panel is a DC product, so we put a solar panel on our wall, and it feeds actually into this panel. So it provides power for certain devices that are in the panel. So it's DC, direct to DC. There's no transformation. It's very, very simple, very, very, very cost effective.
Right. So let me ask you, Zenon, with this. So what we were looking at there is you had the floor assembly above, and then you had the ceiling assembly below. So what we're looking at is you're putting in the ceiling assembly and all the fixtures, and you're plugging into the floor above, because that's what's carrying this plug and play wiring system. Those panels, when you set the floor, is it the same thing? They kind of just clip together and off and run and you go?
Yeah, so basically the panels clip together at the joints themselves and at the other joints. So basically it is that simple. But to be honest with you, the work that we're doing right now on these panels is actually understanding more about those connections, how we make those connections very robust, and how we make sure that the information flows from one panel to the other. Because you can imagine if we now have 400 panels on a floor, all of that flow of information going through those connectors is actually the most complicated component of this system. And that's what we've been spending a lot of R&D time the last, I would say, 6 to 9 months is looking at how to make that connection the most, robust connection that's not going to potentially lose like data and power as we have all these connections.
Yeah. And you're expecting all that to run off DC, right?
Yeah, it'll all be the panel itself, and all the wiring will be low voltage based, whatever's in the panel itself. And it'll then go back to a core, and then eventually transform back to then basically like AC feeds it, but it feeds it at one point in the core of a building. But the complete, outside of the core of a building, that's basically all DC based.
Got it. So you have something that's converting the power just like the plug on my laptop does when I plug it in.
Exactly.
Got it. Got it. All right. Perfect. Love it. Let's hop back into it here.
Okay. So that's the panel, and I kind of won't kind of go through too much more on these actual other sketches because there's just more details about the panel itself. But you can see it's very modular. You can see these connectors we just talked about a few seconds ago about how we connect at the end points of the actual panel. That is called the trickiest thing that we're looking at. But this is a great image of these ports that we plugged into. In the video, they were primarily ports on the underside of the panel, but we could actually have ports on both sides of the panel. They could be on the floor itself. So you can imagine plugging things in from your desk down to the floor. So it doesn't have to be at the ceiling level. It could actually be at the floor level as well, both sides of the panel itself, okay? Now, when we started playing with the DC world and plugging in things into our DC highway of our panel, we realized that a lot of, call it, the devices that still exist outside in the world are still, again, very much AC based, or they're DC based, and they don't have any smarts. Okay, so we basically wanted to create a solution where we could plug in a dumb device like a light fixture, like you see right here, into what we call our black box number one, which is this. This is the very first prototype. It was really ugly looking. We actually exploded it. It was like about 8 inches by 8 inches. This is, call it, version number 3, and version number 4 and 5 we're now at is about half the size of this, even smaller. But what basically black box number 1 does is it takes a dumb DC device like a Home Depot light fixture, and these are actually Home Depot light fixtures, LEDs. You plug it into our actual black box, and the other end of our black box plugs into our panel, or it doesn't have to be the panel, but plugs into basically a computer. And now you control that, call it, dumb DC device. So if it's a light fixture, for example, you can now, you could dim it. You could have it talk to other light fixtures. You could have it talk to other things like roller shades on the windows. So if the roller shades go down, the lights will turn on. If the roller shades go up, the lights will turn off, things like that. So it basically allows us to basically turn dumb devices, things like lights, fans, motors, speakers, whatever it is, into smart devices by going through a black box. So that was something that we realized that we weren't thinking about inventing, but we basically realized that we kind of had to kind of create, because when we started playing in this DC world, we realized there are some called limitations on how to make, parts of our buildings smart. So, there are other products in the marketplace that are similar to this. We believe that what we've done is a little bit different by allowing us to communicate via Wi-Fi and Bluetooth to our devices through a box. So, I guess what I'm trying to tell you guys is that as a firm, when we started playing in our lab, and I've now heard this from other inventors, when you start playing with an idea, usually within a couple of months of playing with one idea, you'll come up with 2 or 3 more ideas. And that's happened in our lab. Like, we all started off with the ISP panel, and within 6 to 9 months, all of a sudden we're looking at 6, 7 different things. So, that's called the fun and beauty about, inventing and having an R&D lab. It really starts to kind of explode and grow in a really positive way, especially when you have a good group of people that are playing and having fun. You go from one idea, and all of a sudden you're looking at things you never thought you'd be looking at. So again, it just how my career is changing, how the profession is changing. It's amazing to kind of do things like this.
I love it. I love it. Zenon, what I want to do is I want to hop over and say hello to some people and take a couple comments that have come in. There's some questions as well. Okay. I think something to think about at the end of this conversation. You're going to have to tell us how you have time to be an architect too. Let's hop over here and say, hey, I don't know if you know this guy. You know Steve Duguay? Hey, Dave, thanks for having me. And say hi from Steve at Think Modular. What's happening, Steve? Thanks for joining us today. I love it. I love it. All right, moving on down the line here. AJ says it's rare to see architectural firms invest in R&D initiatives like WZMH does. I got the Z right. From a business point of view, what are the long-term plans for scaling up commercializing these initiatives?
So that's a great question. And, I think kind of to answer that question, there's some history behind this. Again, at the beginning of the show, I kind of talked about, we got into this because we wanted to kind of showcase to our clients that we think outside of the box, that we're different than our competition, right? So we started creating these great ideas, cool ideas, but the intent was really to kind of create them, show them to our clients and say, listen, here's opportunities that can be called studied, but we know they're not ready for today or tomorrow. They're probably ready for the next 2 or 3 or 4 or 5 years, right? But by showcasing this to our clients, they were saying, wow, you guys are basically innovative. We're going to hire you for the next job, right? Or if we were competing, clients would say, you guys are different, we're going to hire you. But what happened very quickly is a lot of clients were looking at this stuff and said, wow, this is cool. When can we have it, right? And so, we kind of stepped back, scratching our heads, thinking, well, wait a minute, this is not really the business that we're in terms of making black boxes and making ISP panels. So how do we actually move this forward? So we realized very quickly, let's partner with other industry partners that actually specialize, for example, in building black boxes or making these steel panel floors, right? So that's our business model moving forward, is with all of our ideas, we very quickly look for partners that could actually help us take this and commercialize it. And then we just move on to the next idea. Make sense?
I mean, yeah, it makes a ton of sense, right? I love it. AJ, thank you so much for your question. Charles Warfield, good morning from California. Hey, Charles, thanks for joining us today. We got Andrew Seeley from G-Pods joining us. Look at that, he says. All right, now this is a character I haven't heard for a while, from Steve Burrows, man. How are you, Steve? He's asking, are these SPS panels?
So the original one is an SPS panel, a sandwich plate system. As I mentioned, it was developed in Canada and the UK, a steel plate, resin core, and a steel plate. But since then, we've actually, with one of our engineers, come up with our own solution where we've actually eliminated the resin core. So we have a version of the SPS that does not have the resin core. I can't tell you what that is because it's proprietary. If we did, we'd be basically giving away our secret. But it started off with SPS. SPS, as everybody or Steve knows, is a modular, steel floor system, and we've been using it in buildings as a, again, replacement for concrete and steel deck. And that's where our idea was, hey, let's insert our highway inside this resin core before they put the top plate on. So that's how we came up with the idea. So it started off with SPS.
Good, love it. Hey, Steve, thanks for joining us today. Good to see you out there. All right, moving on. Buzz Holitzer says, cool stuff. Love it. Hey, Buzz, hope you're well. Thank you. All right, Steve Burrows, are the ISP panels actually deployed in some buildings? Was a follow-up question.
So we're getting very close. In fact, this morning we had a workshop with a university in Toronto where we're going to be doing a very small little building, 2-story building that's going to have these panels. So we're going to start seeing it deployed within the next 12 months, maybe less than that, in Toronto. COVID kind of delayed things, believe it or not. This particular project should have started, probably about a year ago, but because of COVID, it's been delayed. So everything's been delayed in terms of rolling this out. But we're starting to kind of, now get back into the swing of things. And, hopefully this building will be built soon to actually have it showcased.
Yeah, perfect. All right, great. Listen, let's get back into what we're talking about. And I have the other video where you show the floor sensors as well. We're going to talk about floor sensors and what they do when you walk on it.
Sure. Why not? If you pop it up right now. We'll do a quick little review.
Let me grab it real quick here. I'm not going to play the sound with it.
Okay. But basically, I mean, just to kind of as a follow-up to this video, again, the whole idea about the ISP panel was, making this panel that's called very, very smart, that basically allows us to basically put in technology in the panel, do different things. So we actually played with the idea of putting floor sensors actually in the panel itself. So as you walk on it, you have an understanding of where people are actually walking and things like that. We haven't spent a lot of time since doing this because there's other technologies that are available that might make it simpler, and it'd be pretty costly to actually do this in the panels. But we want to kind of play with the idea, can you actually put these sensors below the first steel plate and actually have the sensor kind of go off? And the answer is yes. So a little study that we did that actually works.
So what is the purpose of that, though? Help the general audience understand what would be the purpose of tracking people's patterns.
So it's not so much about tracking people, but it's really about getting that data to basically understand how people move within a building. So for example, about a year ago we started working on we did, but it's been put on hold again, is the idea of if we have the right data of how people move in buildings and combine that with artificial intelligence technology, can we get to the point, for example, where I get up from my desk, at my office, and as I start moving, the computer does a calculation that says, the chances of Zenon actually walking towards the elevator core is like 99% just based on, movement patterns over the last year. and chances are he's going to the elevator to actually, go down the building, meaning as I'm walking out of my office, it already calls the elevator. So the elevators become that much more efficient. So if we could start kind of designing buildings to kind of understand how people move, we could then start making systems in the building more efficient. So you can imagine if you've been to some office buildings that have 30 elevators, right? If you could now make buildings more efficient and the elevators more efficient, maybe you go down to 25 elevators. I mean, an elevator alone, it could be worth millions of dollars in construction costs and then ongoing operational costs and then real estate value. It takes space, right? So understanding how people use buildings could actually allow us to design buildings that much more efficient, make them potentially smaller, more cost effective, all that kind of stuff. So it's really about understanding how people use buildings. That's how we want to kind of use floor sensors or similar things like floor sensors.
Yeah, I mean, it makes completely, completely makes a lot of sense to me. If I think about some of the high-rise buildings that we're in and all the elevators and, people on different floors are letting out at different times, and then you stand there for 5 minutes waiting for an elevator versus the efficiency of the elevator could already be there, as opposed to all that energy being spent at one time, taking 10 elevators to one floor. I'm with you. I like it. I think it's a great, great concept. All right, let's hop back into it here.
Okay, so back to the presentation. So black box is a fun thing. Again, it started off, we're actually at like black box number 6 or 7, which I'll talk a bit about black box 5. Black box 5 is meant for very much the residential marketplace, whether it's, condos or rental buildings or even houses. And what we're doing in black box number 5 is taking a traditional electrical panel, okay, adding a DC component and basically picking a whole bunch of items in an actual basically residential building. So all of our lights, all of our fans, things like that, even some plugs, and basically run them back to black box number 5. They'll all be DC wired, okay? And black box 5 basically has inside a electronics component that actually we communicate with via Wi-Fi, and so basically turn a residential unit into a smart unit, okay, with devices that are all dumb. All the lights, all the things that run back to our black box 5 are all just typical normal things, typical normal lights, roller shades, etc. But because they're DC powered and because basically we have Wi-Fi access to this panel, again, now we can control all those items via an app or via from your computer, whatever it is. So you basically turn these spaces into smart spaces without actually buying all these, call it smart things that you go to Home Depot to buy. You don't have to buy that kind of stuff. You could basically just have the highway built in a smart way and plug in dumb things, but because they'll communicate through the panel, they become inherently smart, right? So that's kind of our idea too behind these called the smart home, smart buildings, is not to get into the gimmicky things that you buy and plug in all over the place. Create a smart highway, and you could plug in whatever you want, but because the highway is smart, at the end of the highway, at the very, very end, the computer that everything plugs into, that gives the smarts to all the devices. That's basically our approach to smart buildings. It's not about buying all these fancy schmancy gadgets you put all over the place. We don't need that stuff, and that stuff we know after a couple of years is old and you got to replace it. Our focus is create a good highway, and whatever you plug in, doesn't matter what it is, because it's a good highway, smart highway, it'll become smart.
And that's less stuff in our landfill. I mean, if you really think about it, right? I mean, if you look at the environmental impact of something like this, that means I could take something from 10 years ago, plug it in, and it becomes smart all of a sudden because you're controlling the power and the flow and telling it what to do. I love it.
Exactly. That's a very good point about reusing older things. So maybe I'll go a bit into prefab. So when we got into prefab a couple of years ago, we've looked at it in many different ways in terms of prefabbing complete buildings to components, whether you're prefabbing bathrooms or living rooms, etc. But we've looked at it in many different ways, and we're doing buildings from prefab in the exact same way. It could be complete modules or components, and there's advantages and disadvantages to that, right? I won't spend a lot of time on that because I think you've probably done a lot of shows on prefab, and so your viewers have probably seen that kind of stuff. But a few things that I'll focus in on is our ISP panel, and this is actually the SPS panel that can be the ISP panel. That's basically, again, showcasing this idea of a very, very thin floor system that's as strong as 8 inches of concrete, but it's thin. So you can see the advantage here in this section detail. typical called condo edge detail, where you have this 8-inch concrete floor, and you have this called large spandrel panel at the edge of the building. Well, if you go to our thin floor, all of a sudden the designers, architects, for example, could now play with the exterior a lot more and bring the windowsill lower or do different things, right? So, again, going to good prefab solutions all of a sudden now opens the door to potentially more creative solutions on the architectural slide. I think a lot of people think the opposite. They think, oh, prefab is going to limit what I can do. We believe it's actually the opposite. We believe it's going to start opening the door for designers to actually having a lot more called opportunity to do things that they couldn't do in traditional means, right? But I think that's a bit of a roadblock for a lot of people, where when they think prefab and modular, they think, ugly building blocks kind of stuff. And what we're realizing is maybe that is the case, but it's changing very quickly, and there's going to be a lot of opportunities when you start integrating these new systems made out of traditional materials but built in a different way. It's going to really open up opportunities for designers.
Yeah, very much so. So, I mean, how do you make that floor so thin? Walk me through that, or is that proprietary? I'll have to kill you if I tell you stuff.
Well, no, that floor is the SPS floor, so it is that thin SPS steel plate, resin core steel plate. So, I'm not a structural engineer, but basically, it's so thin because it's structural. They've designed it that way. So that plate and that sandwich, the way it's bonded together, it has those structural, call it, characteristics that allows it to span the same thing that basically an 8-inch concrete floor spans for that similar loading, right? So it's all about the structure itself that allows you to make it that thin. When it was invented, apparently it was invented to basically replace, an inch thick boat hull or ship hull. So instead of being solid steel, they came up with this idea. It's a lot less steel, a lot less weight, right? So that's where the invention kind of started. Then it went into bridge building and all that kind of stuff. And then it went into the building industry. People realized, hey, this is strong. It's light. Why don't we use it for buildings? So it's now kind of evolving into the building industry.
Yeah. And I can see this. I mean, if you look at even the commercial modular offsite construction world, if we can get away from, using, 5-inch concrete floors and go to something that's more lightweight, such as this, there's a cost savings not only on the install and how you pour it and put it in, but there's a cost savings on the transport, a cost savings on the size crane. I mean, it kind of snowballs down the line to the efficiencies of what that can bring. And then you add the cost savings of the wiring and everything else that's within the smart floor. I could introduce you to a bunch of people that'd be interested in talking to you about that.
Okay, cool. I mean, the other thing too is also great. Height, right? Like if you think about height in a tall building, 30, 40 stories, if you start adding up these inches you save, you'll either make your building shorter, right, if you want, or you can make your building taller within the same height. You can have more floors within the same height of a traditional building. So there's a lot of advantages to making this floor thinner versus thicker.
Yeah.
So again, this is an example that a lot of, for those of you that have been kind of following the Toronto, Canada, call it marketplace, it's been a boom for the last, 15 years in the residential high-rise side. There are a ton of basically condos and rental buildings popping up everywhere in Toronto. The skyline has really changed drastically. And so every developer is really looking at, how to build the better mousetrap, how to build the better condo, more efficient, give basically the end buyers, call it more space, for example, better quality. So we started looking at, for a few clients, prefabbing components of a typical condo unit, the bathrooms, the closets, the kitchenettes, the walls that surround the actual HVAC unit in the corner. If we prefab these things and we build them in a factory, we could actually save inches here and there, everywhere, right? And those inches that we save, in some cases 3 or 4 inches, makes a big difference in these very small, tiny units that are 600, 700 square feet. We start to add potentially 10, 15 square feet to an actual unit. But more importantly, we start to kind of create rooms that actually, by gaining 6 or 7 inches, the difference is going from, a double size bed to a queen size bed, for example. So all of a sudden now these clients can now go to the people that are buying these units and say, listen, if you build it if you buy our unit built in this prefab way, we could actually give you a bit more space, more usable space than the competition across the street. So again, there's a lot of value to prefab in terms of, things like this, where we could actually build our buildings that are smaller and therefore save money building them, or give space back to the end buyer and say, look, our suites are a bit more efficient, right? So that's what this is all about.
No, I love it. So what talk to me a little bit about some of the acoustical values of this system and what have you. So do you have to, it's thinner. Is that a concern?
No, it's actually for the ISP panel, the SP's panel, the acoustical properties are very similar to that of basically 8 inches of concrete. So acoustically, it's almost similar. You know,
Okay.
when you walk on a steel plate, that's a bit different. So you deal with that through different materials we put on top in terms of carpeting or cork, screening between the finished floor. But acoustically, it's very similar because its structural properties in terms of its loading is very similar to 8 inches of concrete. So acoustically, it's pretty good as well.
Sure. I love it. I love it. Let's go to a couple questions, Zenon.
Okay.
All right, let's hop into this over here. Steve DeGuay is back. He said, let's install modular cabling for this this test site. Whatever test site that is. All right.
So I will call Steve after this meeting or after this presentation, let him know about this project in Toronto, which, thanks for reminding me, Steve, because you know what? It makes a lot of sense. And I think we have a second call February 2nd or February 3rd. I'll get you on that call.
Love it. There you go. All right, Steve, send the check in the mail, man. No, I'm just kidding. Just kidding. All right, Joe Butler. This is brilliant. We could really understand the fact we spend 80% of our time in only 20% of our space and use data and analytics to reprogram the consumer of housing products and housing product development. So just so you know, Zenon, Joe Butler is Forward Solutions Group. He is our sponsor of today's show. So thank you, Joe, for joining us. You guys should definitely talk. Joe's out of Canada as well.
Oh, great. That's good.
So I appreciate the comment, Joe. And all right, Steve Burrows is back. Man, he's here stronger than ever today. Given the life safety and code issues related to, say, fire and vibration, what has to happen to make this scalable?
So one of the key things really, and we actually did a building in Toronto out of SPS. We got our permits in place. It still hasn't started construction, but basically, because it's steel and it's not concrete, you have to basically fireproof it, right? So right now, a lot of the tests that have been done in North America are related to basically spraying the underside of the panels with basically like a spray type of fireproofing, right? Or you use like gypsum board, for example. Currently, right now in the UK, the SPS guys are actually doing tests with intumescent paint, okay? And they're going to get approvals in place to actually have these panels basically painted with intumescent paint to provide the fire protection. So that's where we'd love to see this go. And then again, that's another great advantage of in terms of the prefab modular world. You can imagine having these panels prefabricated in a plant, painted with intumescent paint, right? And then delivered to site, installed, and now all of a sudden
Right.
your fireproofing is done as well. So that whole concept of 10 in 1 that I talked about becomes like 11 in 1. You keep adding more and more things to this component. When it leaves the factory and it's dropped into a building, a lot of stuff is done by a lot of other trades that no longer have to show up. So, that is the future. That's where things need to go. And, the SPS panel or the ISP panel, the examples you saw that had a ceiling, doesn't need a ceiling. We could just install the panel, have things hang down. And so now that sprayed fireproofing is the paint finish as well. So the story gets better and better and better.
As you continue on. I love it. Well, listen, Zen, we're at almost 47 minutes into this already. So why don't we hop back into your presentation? If anybody out there, if you guys have questions, you got to get them in because we will be wrapping this show up on the hour. So ask them now. Here we go.
So I won't spend too much time on this, but this is an example of a prefab building built out of modules. And what we tell our clients is prefab buildings could look amazing. And this is an amazing looking building. But I want to talk a bit about this. This is a cool initiative that we started last year, right when COVID kind of came to North America and shut us all down around, I think, end of March. And this idea we came up with one of our clients, a guy named Carl DeMarco, and we were thinking about how do we keep construction sites safe? How do we basically keep construction sites going, and not stopping because of COVID? So how do we do it? So we came up with this idea of creating the pod in a sea container, a testing pod, a virus testing center, where basically people could walk up, get screened and tested for COVID, and then basically enter the construction site. So it ballooned from that to actually being these pods being built and being installed in universities, at airports, at medical facilities, at colleges, etc. And we basically picked a sea container simply because speed to market, very durable, very fast to assemble. So we partnered with a company called PCL Construction, Canada's biggest builder. They're also a big builder in the States. And basically, they retrofitted sea containers in about a 2-week period from the time a client says, we want one of these, to the time it was finished was around 2 to 3 weeks. And so a great, call it a great success story. We're very proud of that. We were able to kind of do something and support, kind of what's going on in the world.
Right.
And it is still growing today. We're still getting a lot of calls from clients that want these units. And so it's another called side project of the firm that's doing these pods, on an ongoing basis.
Well, not just for COVID. I could see this for anything around the world. We look at Ebola and all these other, pandemics that are happening in different countries. Yeah, amazing.
Yeah, and in fact, so we got a call from the UN. The UN are looking at wanting to get 100 of these units sent to Africa. So we're having discussions with them right now. So
Wow.
so yeah, and they're thinking the exact same thing. It's got a lifespan beyond COVID. It'll go into doing other things.
Love it.
One thing I want to talk a bit about is wood, because wood is a big issue out there these days. I'll talk about wood construction. So we started looking at wood as well, and we came up with this idea for a modular wood floor system, similar to our ISP panel, but it's wood, but obviously it's a lot thicker. It has a cavity, but the beauty about this is it's a complete plywood solution. So the ceiling, the floor, and the joists are all made out of plywood. And people ask, well, why would you do that? Well, the idea here is that these wood floor systems get built in a automated plant where everything is basically cut with saws. Basically, it's all pre-cut and then assembled with automatic machines that nail and glue. So it's the same product: the ceiling, the floor, the joists. Okay, different thicknesses though,
Right.
and that solves a lot of problems in terms of shrinkage, all that kind of stuff. We're dealing with one material, recycled, and we can get plywood sheets that are long. They come in sheets that are longer than 8 feet that we're familiar with. We can get sheets that are 15 feet long. So we created an actual module that's 4 feet by 15 feet, that's thinner than a 2x8 joist. So we get spans because the plywood is also structurally a lot stronger than a typical
Right.
cut lumber joist. And then again, in the factory, we'll assemble and install, all the wiring and even the ductwork that goes in these panels. So you can imagine these panels being delivered to a site, and this is meant more for the single-family home, 2, 3, 4-story type of residential building. You'll
Right.
drop panels in place, and again, have a lot of the infrastructure, pot lights cut out, all ready to kind of install on site.
And this is going to have the same plug and play effect, right? I'm verifying that that's what you're talking about here. So interesting. And what would you use? Like a panelized manufacturer to put this together in an automated fashion?
Yeah, that's the idea. Basically, working with a company that specializes in assembling, called wood products, that has called the space in their plant, assembly line space that could actually have all these components pre-cut, glued, nailed with robotics, to high level of precision, and then basically, delivered to the site.
Yeah,
and
for sure.
The images on the right, I won't spend too much time, but is the idea, and we're building some large scale mock-ups of partitions that are used in office buildings, or say in we do a lot of retail banks. The partitions that separate the offices are built out of basically this very thin, less than 2-inch thick plywood, call it a system. It's a wall system, basically plywood with an insulated core. And we've now built some mock-ups I have, I could send you later on, that actually show wiring inside. Again, a low voltage layer inside the actual sandwich.
Outstanding.
So if I could, should I keep going, or do you want to?
Yeah.
Do you want to?
Hey, listen, I'm on your schedule, man. We'll go as long as you got.
Okay. So this is something that's in development. It's a cool thing that we developed, and this is, call it, when our firm started looking beyond physical things that are typically in buildings, like the walls, the roofs, the floors. And because of hiring people that are software related, we started looking at apps and things like that. And we've realized, as a firm, in designing, energy efficient buildings and stuff like that, to really kind of push the envelope to make buildings called very efficient, energy efficient, and called, pushing the net zero spectrum and all kinds of stuff, you have to now think beyond the buildings. You now have to empower people to help these buildings actually achieve net zero, or take them off the grid, or whatever. So that's where we came to this idea called My Sun. And My Sun is all about empowering people through the use of an app to actually create their own energy. That's why it's called My Sun. It's your own sun. You create your own energy. So it starts off with simple things like you buy your own little solar panel, a little panel that's 4 inches by 8 inches or whatever, any size, and you take this panel with you wherever you go to buildings the buildings must have called the highway, the DC infrastructure built into the highway, and a battery storage system. So you might plant this little solar panel that you bring with you at your desk. You might take it, to the cafeteria where there's a lot of windows, or you might take it outside in the courtyard of the building where you can plug things in next to the bench outside. And basically you generate power. And that power goes into the building's battery system. And basically other parts of the building then feed off of that battery, whether it's the lights or whatever it is, feed off of that battery that's receiving green energy that you created because you're basically carrying that panel around. And it's tracking all the energy that you create through your app. And you could then start, for example, tracking how much energy you create, compete with other people, and corporations will come on board and actually sponsor this and provide rewards for people that generate the most power. But it started off with a simple idea as a solar panel. Now we're looking at like 5 or 6 other ways that people generate power. So simple things like taking a bike that has a dynamo charger on it on your back wheel, driving that to work, riding to work, plugging that bike into the building's, again, DC microgrid, okay? And that building's DC microgrid then takes that energy that's stored in the battery from your bike and uses it again to feed other parts of the building. So things that you do when you're exercising, riding your bike, you're creating power, your own power that you feed back into the building's, battery system. So again, we take the concept of the bike, we put simple little bikes on each floor in a wellness room. So you want a bit of a break, you're stressed out at work, go in the wellness room, ride that bike for an hour or half an hour or 20 minutes, doesn't matter. It has a wheel that has a dynamo charger that's, again, connected to the building's battery system. So you're creating energy, you're doing energy. So you can imagine people will start doing this, competing against their friends, their co-workers, companies against companies, who could create the most green energy, and that's the whole concept behind this thing called My Sun. It's about empowering people to basically see if they could create their own energy and give back. And so, the app is going from solar to things like the bike to things like walking to work or taking the subway. By instead of taking the car to work, if you take the subway or you walk or take your bike, you'll get more points. You'll be penalized if you take your car. Things like that give people an incentive to basically help change the environment, and the corporations will basically provide rewards. If you're the leader this month, you get a free Starbucks card, for example. That type of idea. That's the whole idea about My Sun.
I got an idea for you, right? But you have to promise online that if you do it, I'm part of it.
Okay, I'll for sure. Shoot, what's your idea?
Wouldn't it be great if you could find a way to generate power from people typing on their keyboards all day long in all these office buildings and generate power back into the system?
Well, it's easy. It's already done. It's what they call piezoelectric power. So basically, small little sensors that actually vibrate. So we're not actually looking at that, but that's actually. But now that you told me, I'm going to look at that, and we're going to credit you for sure.
Yeah, just send my check in the mail with everybody else. I love it.
Okay.
Perfect. All right, keep going. I didn't mean to derail you.
So these are just other examples of we're doing a lot of work on the solar photovoltaic side and looking at what they call bifacial panels. But we also believe there's an opportunity because solar panels are becoming a lot more efficient these days. Right now we're collecting a lot of power from the we're collecting a lot of power from the outside via the sun. But there's an opportunity because there's a lot of buildings where they leave the lights on, all night long, or even in the daytime. There's still a lot of interior light, bouncing light from the sun, from the exterior windows, but also the lights above. So the idea of actually generating power from artificial light is what we're looking at, right? So right. It's still in the very early days. It doesn't generate a lot, but it's starting to kind of make sense, right? Especially around the perimeter of buildings where you have the light from the exterior coming in and bouncing off surfaces. If we could capture that bouncing off light on the inside through, for example, bifacial solar panels, one side of the panel faces the exterior, so it gets all that natural light, but the interior panel actually captures light from the ceiling, fixtures, but also light bouncing off white surfaces. So our ideas are about, looking at capturing artificial light inside. But all of this only makes a lot of sense if you believe in the DC microgrid or the DC building, because the cost for these systems drop drastically when you plug DC into DC. It makes a lot of sense. And when you have this microgrid where you have batteries in the building, where you could take these minimal amounts of power that are generated, feed them into this grid, right? That's where it makes a lot of sense. Otherwise, if you start looking at this in today's way we design buildings, it's too costly, right? But when you start pushing the DC side, these solutions start to make a lot more sense. And that's why we're looking at them right now a lot more carefully.
Yeah, I agree with you. I mean, it really does. It's almost simply put, it's almost stupid that we're not doing it, to me.
Exactly.
Yeah, for sure. Got it.
And basically our last slide here is, again, a lot of work. And Steve, who was asking some of those questions, he's involved in, and we have these workshops weekly and bi-weekly now about microgrids, and again, looking at how we create a proper microgrid in a building that's very much plug and play, and how we could actually plug in what we call green energy producers into a microgrid, things that generate green power, plug them into different parts of a microgrid, and that all feeds back to the battery storage. That's our goal, to create as many what we call GEPs, green energy producers, as possible. Right now, people think of only solar and wind. Again, we're looking at piezoelectric power. We're looking at different things to actually create, green energy that feeds into our microgrid. And this example on the right-hand side is a section of a curtain wall mullion that has a little fan blade on the outside. We know in taller buildings, airflow, wind flow around buildings could be pretty serious in terms of, generating some power. It goes up the building, around the corners, over the roof. So if we could capture that wind going through those blades, we could generate, called free energy. But it's got to be fed back into the grid in a very cost-effective way. And if it can be, these solutions make a lot of sense. So that's called the last of it in terms of some of the innovation that we're working on.
Yeah, I love it. I mean, some of it. That's a lot of it. That's a lot of innovation. So, like I said, when do you guys have time to do the architectural work, man? I mean, you're not designing small buildings either. You guys are designing some major infrastructure and buildings all over the place. So, talk to us a little bit about that, and then we'll go to some more comments and wrap it up.
So basically, it's obviously, like you said, we have our daytime job, and we have to design these buildings to pay the bills and pay the staff. But basically, because it's very exciting, a lot of staff are willing to put in extra time, whether it's, after hours or even during the day, and they'll work on their real projects after hours or on weekends. This has created a lot of excitement in the office. It allows us to attract a lot of good talent, and people want to work on it. So it's not difficult to get people to work on it, because they're willing to work on it after hours, on weekends, during the day, whatever it is. So because it's so exciting, it's been actually pretty easy to kind of get people involved in it, and it's growing. And I don't know what else to say other than it's been a great great couple of last years, and we only see getting a lot more exciting and better moving forward.
Yeah, listen, I mean, that's part of the culture. That's part of your excitement. You can hear it in your voice. I mean, you're a million miles a minute, right? You just got so much going on. And I think for anybody that works for a firm, or, as a team member of any firm, that allows them the opportunity to be creative and take things to the next level, and, and learn to fail and fail to learn, right? Because that's part of what you guys are doing. Yeah. Who wouldn't love that? Especially you go to architecture school or engineering school, you're there because you're creative. Right. You're just feeding that mind. I love it. All right, let's get to some quick comments here. We got Buzz Holitzer. I like the CCP more than the other CCP.
So what's the other CCP?
I don't know. Buzz, let us know. We got George Ryman from Phoenix, Arizona. Good morning, George. I hope you are well today, my friend. Thank you for joining us. Steve Burrows, again, busy as always. DTE product is ideal for cassette panels, as it's fireproof, acoustically excellent insulation, and high thermal mass, as well as lightweight. Perfect. And he had a follow-up to that. Is the peak of that baseball cap a solar panel? No, it's a fishing hook.
The fishing hook is a fishing hook.
It's a fishing hook, we all know Zenon loves the fish.
Actually, I'm not a fisherman,
I
just so you
know.
know. There's a story behind this hat. It's a bit of a complicated, not a complicated, it's a bit of a story. If you want to hear it, I could tell it to you. But basically, I'm not a fisherman.
Yeah, no, I love it. I love it. All right. Well, listen, we are in an hour and 4 minutes, Zenon. If you're to leave us with anything or what you really want people to understand about what you are and what your firm does, now's your chance. Let us have it, and then we're going to wrap it up.
Well, I think what we really do now very well is integrate opportunities for innovation into our building design. So again, when we look at how we design buildings, we're not looking at designing the same way and building the same way that we were doing them from the last 100 years. We're really looking at the opportunities for integrating IoT and prefab into our buildings. We believe that's the future. That's going to make the difference. That's what clients want, and that's what we have to do. And if we don't do that, we're very much worried that there's going to be companies that are going to come out of left field that none of us have ever thought about that are going to start building buildings, in this way. And so the industry needs to change, and needs to change very quickly. And we believe that we're called at the right time, of the change and being part of it, to ensure that when it does change, we're going to be right there, having the technology, the solutions, the skill set, the people to kind of help us move forward. So we're very much about looking at innovation and how we integrate it now so that we don't get lost.
Well, hey, listen, people like you are what are going to drive this industry forward. And like you said, the industry that hasn't changed is changing, and it's starting to happen. And I think being on the forefront of that and helping push what that change is perfect. And having, people like Steve Burrows and all these other folks that, I've had the privilege of chatting with every once in a while. It makes a big deal. There's some smart minds out there, and you're definitely one of them. And I really appreciate you taking the time to come on this show today and talk to all of our guests and audience that we have and sharing what you're doing, because I think this conversation is going to carry long on after this show, and it's going to live on for a while. So let me just see. We got any more? We got one more comments. Let me see right here before we go. Peter Luke, OIQ Engineering PG, BIPV is the future.
That's bifacial panels.
Bifacial.
So what I was presenting, yeah.
Love it.
And I know Peter Luke too. I'm pretty sure I that Peter Luke. I know that Peter Luke.
Oh, really?
I'm pretty sure it's the Peter Luke that I know.
I love it. Hey, well, thank you for joining us.
Quebec. He's from Quebec.
From Quebec? Canada's in the house. Well, listen, everyone, and Zenon, thank you so much for joining us. We got a great show lined up for tomorrow as well. We have the head of social media for Lockheed Martin, JT Ramsey, coming on our show tomorrow. What does that have to do with building? What does that have to do with anything? It has to do with increasing influence, and we can learn a lot about what other industries do to be so well known and what they're doing on the edge of leading edge of technology, and how they manage the outflow of information to the consumer and to their own professionals in the industry. So that's going to be a lot of fun having JT Ramsey on from Lockheed Martin tomorrow at 1 o'clock. And on Friday, we are talking about carbon. Carbon footprint, you ask? I don't know. According to Mark Bare Naked Willie, who is our co-host on Friday, he says that's the wrong term. So Friday, join us. We're going to talk all about what the carbon is doing to our buildings and our environment, and is it a carbon disaster for all of us? All right, Zenon, that is it. Everybody, thank you so much for tuning in, and everybody else that is out there, we appreciate you. We appreciate all your comments and your questions. I'm Dave Cooper. Zenon Radewych, please follow him if you are not on LinkedIn. We'll see you next time. Thanks, everyone. Bye now. Hang tight, Zenon.